So think about the blind spot here. There's a lot of companies that have these well-known monitored things based on what they think they need right now, right? So they're like, hey, these are the monitors we need. And when one of these trips, we'll jump in and we'll save the day. But what happens is one of those things trips, but you don't know why. You just keep restarting the server. You're actually chasing the symptom, not the actual root cause. You don't know that it's those single bit memory errors in the kernel that are the problem. And you're not monitoring those. You're just like, oh yeah, the server crashed and we're getting too many 500, so restart the server. For the rest of your life, you will be restarting the server every time without clockwork at 3 a.m. And that's that blind spot.
Bandwidth for Changelog is provided by Fastly. Learn more at fastly.com. Our feature flags are powered by LaunchDarkly. Check them out at launchdarkly.com. And we're hosted on Linode Cloud servers. Get $100 in hosting credit at linode.com/changelog. This episode is brought to you by DigitalOcean, Droplets, Managed Kubernetes, Managed Databases, Spaces, Object Storage, Volume Block Storage, Advanced Networking like Virtual Private Clouds and Cloud Firewalls, Developer Tooling like a robust API and CLI to make sure you can interact with your infrastructure the way you want to. DigitalOcean is designed for developers and built for businesses. Join over 150,000 businesses that develop, manage, and scale their applications with DigitalOcean. Head to do.co/changelog to get started with a $100 credit. Again, do.co/changelog.
Let's do it. It's go time.
Welcome to Go Time, your source for diverse discussions from around the Go community. If this is your first time listening, subscribe now at gotime.fm. Stay tuned for all 3 of our GopherCon episodes. What to expect when you're not expecting, the secret life of gophers, and we don't call it Jeopardy, but we do call it Go Panic. All right, let's do this. Here we go.
Hello and welcome to this episode of Go Time, the one where we talk about industry decisions go wrong and how you can find out about it. Joining me today are some people who know a lot about distributed systems that can hopefully provide some significant insight on how you monitor and debug.
No, never mind, that's impossible.
First, returning member, the OG Go Time podcast panelist, Alicia Thompson.
Yeah, same person, different name.
I know, right? I almost said Kimpo, so I'm like, oh no, that's not her name anymore. Awesome.
Yeah, glad to be here. Missed the
Good
show.
to have you. Yes. But yeah, everybody's got a lot going on. So, we're trying to hold it down, trying to do as good a job as you did back then. But yeah, thank you for coming back. So, thank you. For those who don't know, Kalisha works on the Project Valero over at VMware to help you some safety backups and restore clusters. So I'm sure she's going to have some more stories. Knowing when things go wrong there. Next up, we have Mr. Kelsey Hightower, who really needs an introduction to our community if you've been around the cloud space for a long time. I'm sure we'll find out what Kelsey's been up to lately. And I'm sure he'll have some insight on the whole monitoring space right now as he sees it unfold. And last, certainly not least, is Stevenson Jean-Pierre, who's an engineering manager over at PagerDuty. A name that is, I don't want to say near and dear to my heart, because every time I see that notification come in, my heart skips a beat, when I'm on call, but hey, it is what it is, right? Fun fact, Stevenson was actually the TA yesterday at the GopherCon workshop that I taught yesterday. So big shout out to Stevenson for helping me do that. And oh, by the way, yes, GopherCon is actually happening this week. Well, by the time you're listening to this, it'll have been like 2 weeks ago. But yeah, GopherCon is happening this week, and it feels different this year. Certainly, we're not all together in the circumstances of what's going on around the world, but things are happening online. We're trying to have the same, as much of a similar experience and a welcoming and warm experience as we will in person. But it is not the same environment, but we are making the best of it. All right. So, Kelsey, how you doing? I didn't let you say hi earlier.
I'm doing good. I mentioned, for the times that we're in, things are pretty good. I can't complain too much.
Indeed, as you said earlier, the internet works, so that's something.
Twitter works.
Twitter works. Yep, exactly. Get our hot takes, daily dosage. Mr. Stevenson, how's things going at PagerDuty?
Things are good. Hello. Thanks for having me.
I'm glad to have you. So, we're here to talk about the monitoring, troubleshooting, debugging, what have you, of distributed systems and when these things go wrong. So, we know it's not a matter of if, but a matter of when things will go wrong. So, there's a lot of things, there's a lot of places you can sort of start the conversation. So, if you are sort of operating cloud native infrastructure, so there's a lot of levels, a lot of places where things go wrong. Cluster level, do you have enough nodes in the pool? Are your storage systems working? Is your network throughput okay? How do you monitor your pods and deployments and whatever terminology you use for whatever orchestration tool you use? There's a lot going on there, and that's just at the infrastructure level. There's so much to worry about, at the application level, at your container level. There is so much going on. I'm interested in sort of really understanding if somebody is not living and breathing this environment as an operator. Perhaps if you are somebody who's in charge of deploying your applications within this environment, right, you are going to have different needs for monitoring and sort of understanding what's going on when something breaks, right, than somebody who is an operator, right? So I'd like us to start somewhere. There's so many layers, but let's start at the sort of infrastructure level, right? If I'm an operator, right, some sort of orchestration tooling, right, for these distributed systems, like what am I looking for, right? Where do I start from a monitoring standpoint?
Why do I care about this? I think, if I think to my earliest exposure to this thing they call monitoring, my days kind of start around 2010-ish, maybe a little earlier, with a tool called Nagios. Maybe some people are still using Nagios, but this is a world where you have these little agents on every single machine, so that would give you at least this is the machine that's complaining. And we would write all these Nagios scripts, and they would run, and if you did it wrong, those Nagios scripts would be the reason you have an outage, but they would take up so much resources monitoring the thing you care about. They would cause the outage to the thing you care about. But at the end of the day, one thing that was always a burden to anyone that's relying on any of these monitoring things is, should I care about it and why do it? And if you've ever worked at a NOC before, and I have, you just have this Christmas tree of Christmas lights in front of you. And you're like, this thing is always red. And they're like, yeah, don't worry about that one. And it's like, well, why is it even red, right? If it's something we shouldn't care about, then we should just take it away. And I think the holy grail for most people at a high level thinking about this is, what do I care about? And I think for people coming in new, that question can be manifested in, practices like SRE, this thing around SLAs and SLOs. I encourage most people thinking about this, thinking about the lifeboat packet. Where is this request coming from? What parts of the system does it travel through? And how fast or how slow does that need to happen? I think that will help clue you in on trying to figure out what metrics and monitoring do you actually need, so that way when you see it trigger, you know it's something you should care about and then what actions to take.
Yeah, I really like this idea of thinking about the packets and the life of the packet, because I wonder if it's just me, but whenever I think about distributed systems, in my head I think about, nodes and computers and systems, and I have to make an effort to remember the reason for this whole thing to exist is to transport data from one point to another. So it's just data going back and forth. That's what we're talking about. So this whole infrastructure, most of the things that we're going to talk about today is the pipeline that's the conduit for this data to be going back and forth. And yeah, so when you start thinking about the data, the pockets, and the life cycle and replication, then you start pulling in, okay, what do I need to monitor? What are the trade-offs and most efficient? And then you can make better decisions. If you have in mind in the forefront that data is the gold here. The infrastructure is the thing that gets us there, gets us, the gold moving and making money for us.
Yeah, for those that need an analogy, I think, Like there's so much data that you can get from these monitoring tools. If you ever installed one of these kind of metrics and monitoring agents, they collect this wealth of information. And the analogy I think I like to think about here is like when you go ship a package, you put a label on it, and that label kind of represents everything in that box. And it can be critical, it can be expensive, but at the end of the day, you get this tracking number, and they told you that it's going to get to its destination in 3 days. So that's your SLA. And you know what's inside there, and you know why it's important. But maybe the people shipping it don't feel the same way about what's in the box as you do. It could be someone's birthday present, and you want to get there in a timely manner. But they give you back this kind of contract. Here's the identifier, but they won't leak what truck it's on, what sorting facility it goes to. And when you go track the package, right, you go and put the tracking number into the thing, and you see like, look, this thing is on time, it's still at the sorting facility, but don't worry, it's still on time. And I think that allows you to focus on the thing that's important. You need to get there on time. There could be a car or one of the trucks that's transporting your package that has a flat tire. You probably don't want to know about that. Even though it might be interesting that truck 007 has a flat tire and it's going to change things a little bit, you don't really care until you start to miss that SLA. And that data can be used for people who have to reroute the package. But for the observer over the whole platform, it's really helpful to focus in on that tracking number and the package and not the infrastructure underneath.
I think I like Chelsea's analogy there between the life of the packet and the delivery kind of analogy. At some point, there's something waiting on the other end for to fulfill that request, right? Or to have that request fulfilled. And monitoring really helps us make sure that at least we're adhering to that SLA that we've established instead of letting that person have to be able to come back. Like you wouldn't expect a FedEx customer to come back to the store saying, hey, my package wasn't delivered now. I demand to know why. You would expect FedEx to already know the status of that package and know whether or not they're meeting their own SLA, right? So monitoring helps us internally know about these things breaking down before it's the person at the other end or the machine at the other end having to come to us to let us know that something's gone wrong with the process.
Right. It's interesting. We're each like pulling one aspect of what's important to whom here, right? So from using Kelsey's analogy, as the person who sent that package, right, to the recipient, right? I care that it gets there by whatever means that the carrier wants to employ, right? But for like internally, right, the carrier itself, it needs like some monitoring. It needs some observability because it needs to know that truck 007 had a flat tire, that it needs to dispatch another truck out there to swap the load and carry on, right? So like who is responsible, right? Who should be caring about that layer? Certainly not me as a customer sending a package, but some people in there, right, care about the nitty gritty, right? They need observability too.
Well, before we answer who's responsible, we have to look at the architecture and the structure and the requirements and how many layers should the system have, or how many layers does the system have. And then you start thinking, okay, at this level, definitely the customer is not going to be monitoring things at a very low level. We know that. But some answers are obvious and some answers are not. For example, I'm sure there's going to be a system admin there. Should a developer be part of it? You have to map the right people to the right monitoring level.
You have to contextualize that thing to that person, right? So the developer might care about a lower level of monitoring to know exactly what's gone wrong, whereas a system admin might care about the aggregate functionality of that system and understand in aggregate if the thing is performing correctly or not. So yeah, not only are there different members in that chain, but we have to provide the right context in that monitoring to make sure that they can resolve the right level of issue when it does come time to resolve whatever it is that maybe have gone wrong.
I think it also helps to understand like the life cycle of data. Like when you collect raw bytes, that's data. So all these, the tire pressure, is this package on time or not? That's just raw data. It's kind of not useful by itself. And then once you start to put some context around it, then you have the chance for that data to become knowledge. Right? Now the data has knowledge, like these things are late. We're going to have to issue money back. So once the data becomes knowledge, then the people who operate. So if you're a mechanic, having the data light up a tire sensor or telling you that you have a failing alternator, that knowledge will allow you to repair the car. So that's who needs to know about that because you're the mechanic. Now, what you report up to the higher thing is that this truck is not going to make it because of, it's a repair and we need to send another truck to do something with it. So all of this, like,
ragione.
how can we go from data becoming just a raw collection of bytes into knowledge? And sometimes when you can't figure out what to do automatically, that's when we have to start sending alerts. Like, we're at least going to advise someone, like, you know, there's something wrong. I'm going to try to give you as much context as possible. And then someone who is more knowledgeable can come along and interpret that data. So the analytic parts of this, because monitoring is not just a real-time thing, right, where you just look at the screen and react in real time. A lot of people would say you should also monitor the things that didn't result in any perceived failures, right? You know, in that airplane with multiple redundant systems, maybe something did go wrong and it didn't result in a plane crash, but you still should go back and analyze that data to say, wow, why does this component always fail even though it wasn't catastrophic? So I think monitoring then at that point becomes this analytical journey of just having as much data as you can so people can turn that into some form of knowledge about maybe we can predict when we need to repair. So I just think all of those layers, and it's just all about translating data into knowledge as fast as you can.
So that knowledge is going to be, or different knowledge is going to be useful to different customers. The way I like to think about it is that you have customers all the way down the stack, right? From the external customer who's expecting, you know, that the action they took, you know, the value they're trying to derive from using your service, basically that they're going to get that. So you owe them something, but you also owe perhaps your developers, right? Who need to understand, right? We don't need all the data; they just need the actionable piece of information, right? In order to make a change, and maybe it's a business logic error or something. Maybe it's some exception got thrown that, you know, they weren't anticipating. Whatever the case may be, they need some sort of a synthesized information as well. So you're going to have different sort of stakeholders, right, for information to be derived from that data at different levels of the stack. So if that is indeed sort of if we can agree that you have all these stakeholders, you know, for any given request, you have all these stakeholders looking for information, like, what is the sort of the approach here? Do we collect all the things, and then so over time, hopefully we have enough, maybe throw some machine learning at it, or maybe throw some like filters and then know that, okay, this particular archetype of a customer, this is what they need. What do? Do we collect wide events for all the things all the time? Like, we're gonna run this page, right?
I think the answer could be all the above. It just depends for whom. For example, whenever I hear speed, I think about the trade-off speed is accuracy. So, do I need it fast or do I need it accurate? Am I willing to wait longer and get more accuracy, or do I need it fast and just have, like, okay, I know these knots, I know I'm gonna make some assumptions here because the data is not complete. So you really have to ask the questions, like, who is this for? What do they need? Not necessarily what they want, because sometimes we think we know what we need. But it's just what we want, and what we need might be different. Or what the client needs might be different from what they want. But you know what I mean? It's like what people need. Basically, you have to have the experience of sort of predicting and anticipating. These are the problems you're going to run into. This is where you're going to just keep asking questions, I guess, to answer that.
Yeah, I think having people just mine for data and try to figure out what they need is, I think, kind of the things we all fall into the trap of. Like, hey, we need monitoring. That's very obvious. So let's install monitoring agent X. And then monitoring agent X gives us like 1,000 signals. So we're like, hey, let's put them all on dashboards and, you know, go to Best Buy and hang a flat screen TV upside down and show everyone, you know, all of our metrics. And it's like, why are we looking at this? I don't know, but the graphs seem to be looking good. Let's set some thresholds. And that's working backwards. So I guess on one of your questions is, what data should we collect? Well, depending on how much you have, how much money you have, what's your budget, you know, collect it all. Why not? And then at the top of that, though, is why? Like, for some of the banking customers I work with, or when I used to work in finance, you would say we lose customers' confidence if they can't check their bank balance in less than 3 seconds, right? From login to seeing their current balance and their most recent transactions. We can't see that in 3 seconds. The customer starts getting nervous and they start calling us, or they just believe that our infrastructure was reliable. So having that top line item, now if I'm a developer working on the presentation layer and I know I got 3 seconds, then I want to know how I'm doing, right? Someone will say, well, we're doing bad. We're at 10 seconds. And it's like, well, how much of this is on me? Like, I'm only doing the front end. And we go and look at the data, and the data says, well, On your front end, you're at 2 seconds, and it only leaves a second for everything at the back end. So where is the bottlenecks at? And then that will drive some behavior to change things, right? So a developer probably wants curated dashboards based on what they care about. And of course, debugging is a whole different thing, right? When you're debugging, you don't know where the problem could be, right? So then you want to have access to much data as possible to probably give you a hint. But then once you figure that out, maybe that does become a new kind of metric that you look at wholesale to indicate a problem like that in the future.
I think maybe you said this, Kelsey, or maybe I'm complimenting what you said. You have to think, are you actually looking or doing something with this information? So that's one thing that I wanted to say. Because you can say, oh, yeah, sure, I have the money. I have the resources. I can collect all this data. But then are you looking at it? And are you taking actions? Even if the data is actionable, are you, as a culture of your company or of your entity, taking action? That's one thing. And another thing I wanted to bring up is I love dashboards. And I think dashboards, they have to be throwaways. Like, I want multiple of them. I want to discard them, create new ones very easily. And I want to see, because today I might be interested in some slice of the data, and tomorrow I might be worrying about something else completely different. So, yeah, it's so much that goes into this. I don't build monitoring systems, but people who build that, it's probably fascinating.
I want to push back a little bit on the data collection piece. You might have a business idea 10 years from now that you can't execute on because you don't have the historical data to do anything with. So a lot of people who are doing well with predictive things or ML, they're only doing well because they have data going back so far that they can do things that companies can never do because they're going to have to wait 2 or 3 years or 5 years to even get the data to even attempt to do. So you just got to ask yourself, like, again, if you have the budget, in some cases, you can collect a lot of data, especially this data, because it may be able to be useful in a way you don't understand. Like, ML wasn't a popular idea for a lot of people 5 years ago. But if you have 5 years worth of data about airline maintenance, now you can apply some of these techniques on that data because you were collecting it all. So in a lot of those systems, not only are you collecting things about your current system, if you think about like when you manage large data centers, you're also correlating that data with historical geo data. What was the Earth doing at this time? What was the temperature like at this time? Because all of that data will allow you to ask questions maybe later to predict new things. So I think, again, it comes back down to cost. So this is why you have a lot of data brokers. You have companies like Esri that provide geo data. You have things like the Maps API, the location data, because we rely on all of these companies to collect all of this data and put a little context to it so we can combine it with our data to ask questions. And I think the last thing about the dashboards, think about your car. The context of the car is kind of static. How fast if I'm going, because if I go too fast, I get a ticket. And a lot of times we do want that static dashboard when we know it's something that we're going to have an SLA on, contractual. If you're a bank and those balances are off or too many credit card declines if you're in the processing business, that's going to be this static thing that's like front and center. Hey, declines are going more than, 7 milliseconds, and Visa will actually have the answer for you. That's going to come with the cost. So I think to your point was like context, right? If I'm debugging, I want to be able to have a different dashboard with that context. If I'm looking at the health of the business, I might have a more static dashboard that leads to that particular context.
So I feel like I'm hearing some conflating between two types of topics, right? So when I think about monitoring, I think about real-time-ish event. Like in some regard, of course, you want data for analytical workloads, so you could maybe predict something about a business or predict something about failure rates of certain systems. But when I think about monitoring, I'm thinking about the type of data that are helping me yield real-time results and getting things better.
So think about the blind spot here. There's a lot of companies that have these well-known monitored things based on what they think they need right now. Right? So they're like, hey, these are the monitors we need, and when one of these trips, we'll jump in and we'll save the day. But what happens is, one of those things trips, but you don't know why. You just keep restarting your server. You're actually chasing the symptom, not the actual root cause. You don't know that it's those single-bit memory errors in the kernel that are the problem. And you're not monitoring those. You're just like, oh, yeah, the server crashed, and we're getting too many 500, so restart the server. And for the rest of your life, you will be restarting the server every time without clockwork at 3 a.m. And that's that blind spot.
But that's a good point right there, right? Just like you have your tire pressure sensor, right? It's there to monitor your tire pressure. It's not there to tell you that you have a nail in there or that you hit a curb hard enough to depressurize the tire, but it alerts you that there's a condition in the tire for you to go and investigate further. So monitoring is that sentry on the guard wall letting you know that, hey, some condition is bad. Now it's time for you to put on that debugging hat, to put on that other hat, to go dig further and figure out what needs to be done. What you do with that after the fact is up to you and your organization and your maturity, right? Whether you follow through and actually get down to the deep root cause and fix it, or you decide to just keep restarting on a cron job just to, to patch you there until you could get better. That's up to you. But the monitoring aspect itself is about, hey, how do I know when something's gone wrong, or what's that signal that lets me know that something needs attention? And I kind of feel like what you do after the fact is up to that respective business or whatever maturity you have.
So let's dig that. Can we pull on that thread? I like this one though, so that's why I'm going deeper. So when you run over a nail, usually the nail is still in the tire, or you can go and actually touch the tire, physically inspect it. And most of these distributed systems, the data's gone. It's gone. You don't get to rewind the clock. You didn't collect it. It's a mystery. So what do? We typically will say, damn, I have no idea why this happened. And you say, well, what's our blind spot? It's like, well, I don't know what the kernel's doing. So you say, well, let's go at that, right? And then we've all seen this, right? Like when you're in production and you go at that print statement, like, I have no idea what this variable is right now. Let me go add it and do another redeployment. So I think what we've kind of learned from the metrics world, and I think this is why we get so many metrics out of the box, is everybody hates when you lose that data. Like, damn it, I have no idea what happened during that time frame, so I got to go back and do it. So I think we're probably even talking about the same thing. Like, when you have a blind spot, you don't know what you don't know. And it's only when you get to be able to correlate, like you can see people, there's two parallel tracks. One is like, we're gonna go restart the server. And one team may say, no, don't restart the server. We need to go investigate. So let's pull the server out of the pool because we don't have enough monitors in place to figure out what happened because we want to do a root cause analysis. And we may just spin up a new machine, send traffic over there, and keep this one so we can poke and prod. And eventually say, you know what, this approach ain't gonna work where we keep pulling things out. What we want to do is get to a world like, you know what, like I was speaking from kind of Google's case, we want all the syscalls. We want all the file system stuff. I mean, we got so much that you may not keep it forever, but you get so much and say, yeah, blow away the machine. Because all the things that you can log on to the machine to get, we have. And that way you can start to do this correlation to the monitored fires and then attach the context. So you can go as deep as you want to get to that root cause analysis.
So you're trying to reason about a system in whatever state it was in at a particular point in time. And in my mind, that it's a subcategory of monitoring, which is about observability, right? You want to be able to reason about it. You want to be able to understand what state the system is in, even if it was an ephemeral state. I mean, how many times have we had outages and we're like, well, that was a network blip. And we don't even know why, like it truly failed the way it failed, but we just blame it on something ephemeral because we don't have that observability. So I do agree with you that that is an aspect of monitoring, but the core kind of principle of monitoring in my mind is, sure, data collection, having the right fidelity of data is super important, but the ability to let you know something's wrong in the first place is that very basic bottom tier of monitoring that you need to have. Just know when something's wrong. If you don't have the mechanism for collecting that high fidelity data to tell you exactly what went wrong, then of course you build on top of that to try to catch the thing when it's happening, but that you build that muscle up over time. It's not something that you expect to particularly have at the onset, right? You don't establish monitoring and all of a sudden have syscall level data because that's expensive to implement, expensive to maintain, and expensive to separate the signal from the noise when it comes down to just looking through like rudimentary things, right? So I think there are certain levels there, and what, in my mind, what you're describing is more about reasoning about a system at a particular time, which is more akin to observability and being able to not have to do a bunch of console.log statements to get an understanding of what's actually happening.
So here is where I think things get interesting. So we have to ask a bunch of questions to identify what we need, right? Some answers are going to be super obvious. For example, I'm not surprised at all that Google collects everything.
This area is restricted.
This is the interesting part for me.
Please return to your domicile for
How do you
debugging.
decide to go from rebooting the server to trying to find out and fix the problem, right? Because you reboot the server, it works. Okay, it's a pain, but it works. Maybe you lost a little bit of data, maybe there is a cost that comes with it, but shifting from that to a culture, implementing or buying a system that allows you to collect and investigate and fix, there's a cost too. So how do you make that decision? How, when, what's the risk take? I don't think I think it's a rhetorical question. I don't think there is an answer.
No, there's an answer.
I don't know. There is, okay.
Yeah, it's around maturity. Our industry is very immature. Like going on a box and restarting it and not know why it happened, that's immature. Like that is just not mature, because I don't want to have my airplane be like, yeah, we got to reboot the plane. It's like, whoa.
This area is
Why
restricted.
are we rebooting the plane?
But that's what I'm saying, Kelsey. The answer to that is going to be obvious in some cases. Yes, the plane is an obvious answer. Yes, you don't want to be rebooting.
But think about any system.
But what about like the gray areas, the companies that are not too small, not too big? I mean, if they're too small, like they're just gonna keep rebooting. They don't even know if they're gonna be around a year from now. So yeah.
I think the goal of people who build programming languages and runtimes and platforms like Kubernetes and Prometheus and Sysdig, what we're trying to do is make it easy to do the right thing.
system to retrieve lost
Right? Like if
objects.
cost is a problem, maybe what we can do is say, well, how about this? If we'll keep 5 minutes of back data, and whenever your monitor goes off, we'll go and snapshot the 5 minutes previous of the entire world, right? The network, the kernel, and maybe have 5 minutes back to at least give yourself a fighting chance. So what we're trying to do is say, you don't have to make that trade-off. I think, I don't want to pick on Boeing here, but remember, I think they made one of the safety options an optional feature. It was optional, like you had to buy it. Like, I don't know what that quite is, but I'm great. But then the pilot needs it to make sure the plane actually takes off. So we can't, what we're trying to do is say, look, let's not make this thing a small or big organization decision. What we want to do is have the platform be at the ready. So maybe we start with 5 minutes of resolution and it's there by default. But yeah, like if I got to write a root cause analysis, like if you're a bank, maybe you're a small bank, your customers might want to know why their balance is off. I need to know exactly why the balance is off. Regulated industries tend to have to be able to give concrete answers to things. And if you're in that situation, and I think we made a good point, Steven, about monitoring, maybe monitoring is where we go from having observable systems and then picking and choosing what slice of that observability we want.
Kelsey, il migliore di tutti.